Hello again. Here is a titration calculation where you have a reaction of a strong acid, hydrochloric acid, with a strong base, barium hydroxide. So this is the reaction that is given to us. We need to calculate the volume. It says how many milliliters of 0.7 molar solution of HCl would react with 8 grams of barium hydroxide. So let's see what is given to us. So we have the molarity of HCl given to us, which is 0.7 mole per dm cubed, and we are being asked to calculate the volume of HCl in milliliters. What else is given to us? We have the mass of barium hydroxide. So the mass of barium hydroxide is given to us, which is 8 grams. So what you could do here is we could convert the mass of barium hydroxide to moles. So the moles of barium hydroxide would be 8 grams divided by the molar mass of barium hydroxide, which is 171.34 gram per mole. So that could give me 0.0467 mole. So that is the moles of barium hydroxide, by the way. Now, if you know the moles of barium hydroxide, you can determine the moles of hydrochloric acid, because the mole ratio of HCl to barium hydroxide is, according to the equation, it's 2:1. That is the mole ratio. So if I have 0.0467 mole of barium hydroxide, that would react with twice as much, which would be 0.0934 mole of HCl. So we use the we calculated the moles of barium hydroxide from its mass, and we use the mole ratios from the given balanced chemical equation to determine the moles of HCl. Now we can go further, and now we know the moles of HCl. If you remember our equation, mermaids need vegetarian diet. Molarity equals to number of moles over volume in dm cubed for HCl. So we know the number of moles of HCl, which is 0.0934, and we know the molarity of HCl, which is 0.7. So as a result, I can calculate the volume of HCl in dm cubed as number of moles over molarity, which is, let's go down a bit further, that would be 0.0934 mole divided by the molarity of HCl, which is 0.7 mole per dm cube. So the mole and mole cancels out. So you get the answer here in dm cube, which is about 0.133 dm cubed. However, you can convert it to cm cubed by multiplying with 1000. That would give you 133 cm cubed or milliliter. So that is the volume of HCl in milliliter. And this is what basically we did here is we used the mole ratios to determine the volume of hydrochloric acid given its molarity and the mass of the base. And that completes the video on titration calculation.